We're fast.
All right. A radical expression can also be written as a rational exponent. We've done a little bit of this before, but we're really going to dive into it today. Radical expression. For example, the radical form of square root of 25 can be written as 25 to the 1/2. Okay, the index becomes the denominator. And whatever exponent is here, which was 1, like 25 to the 1, becomes your numerator. Okay, so cubed root of 27 can be written as 27 to the what? 1/3, okay? And 16 to the 1/4 could... Fourth root of 16, yeah. So your index is the denominator. Your index is the denominator. Got it? Okay. So we are going to simplify each expression. Let's write it as a root, because I'm not good at dealing with exponents like that. Okay, what would that be as a root? 3 squared root of 125. Hey, what's that? 5. Okay, if you don't remember it being 5, you can put it in the calculator or break it down. All right. How you want to deal with this one? Square root of 5 times square root of 5 equals, Hopper? 5. Or we could have added the exponents. So it would have been 5 to 1/2 plus 1/2. Hey, what's a half plus a half? 1. A whole, yeah. Either way, you get the same answer. Okay. Next one. How you want to do it?
10 times 100. Right there.
Okay, so let's write them as radicals first. So cubed root of 10 times cubed root of 100. We have the same index, so we can write it as one big one. And you said 10 times 100, which is 1,000. Hey, what's cubed root of 1,000? 10. Bravo.
You changed the answers up on this. 5.
Oh, I did.
Because it's 5 plus 5 equals 10.
Oh, boom. Okay. All right. A rational exponent may have a numerator other than 1. Okay, that's the only examples we've done so far. All had a numerator of 1. But now, might have something else. Okay, the property a to the m to the n can be written as a to the m times n. Okay, that shows how to rewrite an expression with an exponent that is an improper fraction. Okay, so you can kind of skip steps here if you've got it down. Okay, so 25 to the 3/2. You could write that, kind of separate numerator from denominator. Okay, so the denominator whole thing becomes a half there, and 3 is by itself. So 25 cubed to the 1/2, so that'd be the square root of 25 cubed. All right, just basically your numerator sticks with your radicand. No. The numerator sticks with your radicand as the exponent, and the denominator is your index. Okay. Also, you can write it. This is, I think, useful sometimes. That exponent, the 3, you can write it inside or outside the radical. It does not make a difference. Okay, so that cubed can be inside the radical or outside. Doesn't make a difference.
Where do you get the 1/2? 3 times 1/2. Yeah, where do you get
We broke this fraction apart. Okay, we basically pulled that 3 in front of it and replaced it with a 1. We just pulled the numerator away from the denominator. You can multiply them back together and you get back to the original 3/2. Okay. So this is the definition of how all of that works. Okay, so it's just kind of, the skeleton structure of you fill in your numbers and you can see how it works. Okay, this is what we just added in, that the m stays as the exponent and the n, the denominator, becomes your index. And it can be written with the exponent inside or the exponent outside. Okay, so just repeating myself, basically. All right, so let's do this example. We are supposed to convert to and from radical form. The first one says, write the exponential expressions x to the 3/5 and y to the negative 2.5 in radical form. Okay, let's start with the x one. In radical form, okay, x is the radicand. Where does our 3 go? With the x as the exponent. Where does 5 go? As the index. Very good. Okay, let's convert negative 2.5 to a fraction. 5/2? Okay, so it's y to the negative 5/2. Okay, what do we do with that to make it a positive exponent? How do you make a negative exponent? No. You push it down to the bottom, right? So 1 over y to the 5/2, which is the reciprocal type thing. Okay, now we're going to have our radical on the bottom. So what's my index?
2.
And what will my radicand be? Y to the 5th. Okay, so there are the two answers. Oh, yeah, you're right. I'm wrong. We're not supposed... Oh, no. Okay. Yep. We got to get rid of the radical in the bottom. You're right. I am wrong. Having trouble erasing. Okay. So, to rationalize it, what do you multiply by on the bottom? Or the whole thing? Square root of y to the 5th. Top and bottom. Okay, so that makes the top. Yep, you can simplify it first. Okay, and then the bottom just becomes y to the 5th. Conjugate?
Yeah.
That's for when it's binomial.
Okay.
This time the radical is just by itself. Good question. Okay, so what can we do to the top to break it down?
Take 2 y squared.
Okay, so there's 5 y's, and we're looking for pairs. Y squared, square root of y, over y to the 5th. Okay, now we can reduce with what's outside. What is it?
Y to the 3rd.
Yeah, so square root of y over y cubed. There we go.
Did you really make that so complicated?
No. Sorry. They should have. Okay. Okay, now these will be much more simple. We're going from radical form to the exponential, like a fraction in the exponent. So the first one, it'll be a. What'll be your numerator?
3.
What'll be your denominator? 2, because there's a 2 right there. Okay, next one, what will be your denominator?
5.
And numerator?
2.
Ta-da! Any questions? Okay, to the Okay, so all of the properties that we reviewed right before we started this chapter also apply when you're dealing with rational exponents. Okay, so this is just examples of them. But let's see if we can remember what you're supposed to do. For this one, when you have a to the m times a to the n, what do you do between the exponents? You add, that is correct. Okay, what do you do when it's a to the m all to the n? Multiply, so it'd be mn. Because they're multiplied. Okay, what do you do on the next one? Distribute, so both the a and the b get an m as their exponent. Okay, here's that negative exponent thing in the bottom. It'll be a to the positive m, because it's underneath 1. All right, next one. You subtract, very good, when they're being divided. Next one, distribute, they both get an m.
Those are kind of my initials.
Okay, now, here are examples of all those applying to rational exponents, okay? So you can go through and look at them. Like here, the 1/2 and the 4 got multiplied, which ended up being 2. Here they get subtracted, which ends up being a 1, so on and so forth. If you need examples, there they are. All right, we are going to use those properties of exponents to simplify these expressions. And we can kind of work backwards. I don't know, kind of backwards. Let's write this as a radical. Yeah, so we have our negative 32 underneath. Okay, what is your index? And what's your exponent? 6. So you can put that inside or outside. I'm going to go outside. So that way I can deal with my 5th root while it's a smaller number. Break down 32.
4 and 8.
4 and 8, which is 4 and 2. 2 and 2. 2 and 2. We're looking for sets of how many? 5. Hey, there are 5 2s. Now, it was a 5th root of negative 32. So really, what's the 5th root? Negative 2. Okay, so now we have negative 2 to the 6th. What is that? 2 times 2 is 4. Times 2 is 8. Times 2, 16 times 2 is 32. It'll be positive 64 since it's an even. That's all the negatives cancel out. Ta-da! Okay. Ready for the next one? What is negative 3.5 as a decimal?
Fraction.
Negative 7 over 2, right? Yeah, it's a fraction.
Oh, yeah.
Okay, you want to move it to the bottom now or later? Later. Okay, so set it up as a radical. 2 is your index, so we're taking square root and then we have negative 7. Again, I think it's easier to deal with the root while it's the small number, because what's square root of 4? 2. Okay, so we have 2 to the negative 7, which is going to be 1 over 2 to the positive 7. Okay, what's 64 times 2? 128?
1 over 128.
Yeah. I did 2 to the 7. Any questions now? No? Okay, last example. Remember that the simplest form is writing all exponents as positive numbers. Okay, so don't leave anything with negative exponents. So we need to write 16y to the negative 8 all to the negative 3/4 in simplest form. What do you want to do first?
Multiply your exponents.
Okay, so what all does the negative 3/4 go to? 16 and y to the negative 8. So we have 16 to the negative 3/4 and y to the negative 8 to the negative 3/4. Now what do you want to do? Okay, so we're going to deal with just the 16 for a second. Okay, so that'll be 16, what's the index? 4 to the negative 3. What's the fourth root of 16? It's 2. Okay, 2 to the negative 3. 1 over 2 cubed. Okay, remember, negative exponents do not mean negative numbers. It means fractions. So that is, okay, or 1 over 8. Either one. Okay, and then now let's deal with the y. So what do we do with the exponents? Multiply. Okay, so y, what's negative 8 times negative 3? 24 over 4. Hey, reduce that. Y to the 6th. So what's our answer? Y to the 6 times 1/8, or just y to the 6 over 8. Or if you use that decimal, the decimal would come in front. But try it. Really, we've been avoiding decimals, I guess. Any questions? Okay.